Yeah, hello, good morning. I'm now presenting my presentation, which is about image classification using artificial neural network. Uh, Before starting to elaborate my coding, I want to give a real world example. Uh, if like whenever I unlock or you unlock your phone using facial recognition, a neural network processes my facial features like eyes, nose, mouth, compares them with stored data and authenticates me or you. This technology is actually made possible by a specific type of deep learning. This model is called convolutional neural network, or CNN. And CNNs are not just limited to face detection, they are widely used in medical diagnostics, then autonomous vehicles, plant disease detection, which brings me to focus on my project actually. Uh, the second thing is, in this topic, the goal of my project is to build a plant leaf classification system that can distinguish between healthy and diseased leaves across multiple plant species. And this has a real world agricultural value. With automated early detection can prevent crop loss and improve food security actually. uh, in the thirdly, I want to elaborate my code, and here I used plant leaves dataset. I used contains folders of different plant species. Each plant has two subfolders, healthy and diseased. I began by writing a script to restructure the dataset. I split the image into training 70%, then validation 15%, and test ratio testing is 15%. Uh, then each image has copied into corresponding folders under a new structured directory. This made it easier to feed the data into the model later. Here's a code snipe that creates the structure using was make dirs. It's actually a directory and shuttle copy too. I also created a custom class name by combining plant name and conditions such as tomato healthy or potato diseased. Uh, After splitting, I used Matplotlib and Seaborn to visualize the distribution of classes across the train, validation, and test sets. This helped me ensure that the data was evenly distributed and balanced. I generated bar charts for each split and verified that each class had a fair representation. This is the bar chart. Fair representation. And next I used image data generator from Keras to pre-process the image. For training data I applied rescaling, rotation, zoom, sharing, and horizontal flipping. This augmented the dataset and helped reduce. Next I used image data generator from Keras to pre-process the images. For training data, I applied rescaling, rotation, zoom, sharing, and horizontal flipping. This augmented the dataset and helped reduce overfitting. Validation and test images were only rescaled. The generators loaded image from the folders and converted them into batches ready for model training. I then built a convolutional neural network CNN using Keras by architecture consisted for three Convo 2D layers. Here 2D layers in filters 32 64 and 128, each followed by max pooling to reduce to reduce dimensionality. Then flatten layer I have used, followed by a dense 64, and I added dropout zero point 0.3 layers to prevent over fitting, and finally softmax layer for multi class classification. I compiled the model using Adam optimizer and categorical cross-entropy and tracked accuracy as the metrics. Uh, I trained the model for 20 epochs here. The training and validation accuracy and loss curves were plotted using Matplotlib. This gave me a clear picture of model performance over timing. Finally, I evaluated the model on the test set and achieved a respectable test accuracy. To further evaluate model performance, I generated a confusion matrix and classification report using sklearn. Mm, uh, this helped me analyze precision, recall, and F1 score for each class. The confusion matrix gave visual insights into which classes the model confused most often. To improve performance, I experimented with hyperparameters such as different optimizer, Adam, SGD, RMS prop. Here, dropout rates is zero point 0.3 and zero point 0.5. Number of filters is 32 and 64. Um, I built a function that trained multiple models using different combinations and returned the best one based on validation accuracy. I stored each configuration and its accuracy in a pandas data frame. Mm, pandas data frame, and yeah, uh, and I stored them to identify the top performing model. The best model was retrained and evaluated again on the test data. I printed the final test accuracy, which improved due to better hyperparameters. This approach demonstrated the value of experimenting with multiple configurations rather than relying on a single architecture. Finally, I structured and split the dataset into train, validation, and test sets. I used CNNs to classify image into healthy or diseased categories. I applied data augmentation to improve generalization. I evaluated performance using accuracy curves, confusion metrics, and yeah. Finally, I turned hyperparameters to improve results. And in future work, I would like to use transfer learning with pre-trained models like ResNet or VGG. Uh, yeah, and this is my code. And um, thank you so much for listening me. Uh, yeah, thank you.